Hi everyone! In this video, we will show how to run a univariate Probit model using the graphical user interface and the dataset provided in the GitHub repository. In this example, we use data on hospitalization, where we want to identify which variables are most important in predicting the probability of being hospitalized. First, go to the Univariate section and click on Probit. Then click on Browse and select the dataset from the GitHub repository named 2HealthMed. Once it loads, you will see a preview of the data and all the variables included in the dataset. Next, you can set the number of MCMC iterations, as well as the burn-in size and the thinning parameter. After that, go to the Formula Builder, where you can choose the dependent and independent variables according to the model you want to estimate. Click on Build Formula, and you will see the main equation, which you can edit according to your needs. You can also modify the prior mean, as well as the variance and covariance matrix. Note that when you change the covariance matrix, it may turn red, indicating that it is misspecified, since it must be positive semi-definite. In this model, the posterior distribution is obtained using a Gibbs sampler, which is a Markov chain Monte Carlo method, used to simulate from the posterior distribution of the parameters. Once the model is fully specified, click Go at the bottom to run the estimation. You can verify that the model is running by the message "Working on R" displayed in the bottom right corner. This process may take a few minutes. The app will then generate a posterior summary of the parameters using MCMC simulations. This output shows the estimated distribution of each coefficient rather than a single point estimate. This section reports the posterior mean of each parameter, which we can interpret as the Bayesian estimate, along with measures of uncertainty such as the standard deviation. Since this is a Probit model, the coefficients measure the effect of the explanatory variables on an underlying latent variable that determines the probability of being hospitalized. For example, female indicates that being female increases this latent index, which in turn increases the probability of being hospitalized. If the 95% credible interval for this coefficient is entirely above zero, this provides evidence that the effect is statistically relevant in the Bayesian sense. Overall, the effect on the probability is non-linear and depends on the values of all variables in the model. This output summarizes the posterior distributions of the model parameters, including their central tendencies, uncertainty and convergence diagnostics, allowing us to perform inference in a fully probabilistic framework. Finally, you can download the posterior chains as a CSV file and the posterior graphs as PDF or .eps files. I hope this video was helpful. Thanks for watching.